Okay, so obviously the topic today is the OS Mobile Top 10 Reboot. So the last one we put together was sometime in 2011, and obviously lots changed since then, both in terms of how applications are. Oh, we'll do that in about a sec. Yeah. um, Just have people coming in. So, really quick intros. Cool.
I'm the top one. I'm Jason Haddix. I'm the director of penetration testing at HP Fortify, and a mobile security researcher there. I'm also the lead on this specific project, and this is Jack.
Who's the guy on the bottom there. So been contributing to the OS Mobile Security Project for a few years now. I wrote the OS Go Droid app. It's actually really broken. If anybody wants to kick in some cycles to help fix it, could definitely use them. So why did we actually bother rebooting this project? For starters, things have definitely changed over the past few years. We're using our applications and our phones to do more things than ever and interact with the world around us, including, for example, opening doors. We're moving to the smart home. Throw whatever buzzword you want out there to describe it, but mobile applications are becoming a bigger and bigger part of our lives. We also have new technologies coming out, such as like Google Glass. The whole craze with wearables are about to hit, which is obviously going to change a lot of the use case for applications, likely how we're going to secure them as well. And we have stuff like Nest, right? So this could actually impact, for example, human safety, things that a couple years ago we really didn't consider, but again, we're moving to this kind of world these days. To reboot this project, we had to ask ourselves a few questions. So the last round probably wasn't as data-driven as this round was. We actually had a lot more data to base things off of. But we really want to say, have we gotten better? Have the framework started to protect us against a lot of these common issues that we see again and again and again across applications? And are developers building applications the same way? So, are we standing up, say, for example, a web server, slapping a SQL database, or are we using, say, for example, like back-end as a service type applications? So we looked at a lot of those different things, focused on how the applications have actually evolved over the past couple of years. So our approach, so we used a lot more data this time. We had a handful of companies kick in data, both consultancy types as well as SaaS vendors. So we kind of got a lot of different perspectives, and it's really interesting just to kind of see the differences in the data across the board. We mirrored the web top 10s methodology mostly, so we'll just kind of stick to that. So might actually anybody BlackBerry person here or Windows Phone team or anything? Okay, cool. So when we talk about in a few slides what actually represents the majority of the mobile app ecosystem, iOS and Android kicking everybody else's asses, combined with the amount of applications out there plus market share, it really represents the biggest part of the bucket. So we really focused a lot on those platforms, and we considered what's going on with the other platforms as well, but you're going to see there's a heavy emphasis towards iOS and Android at this point. We had some contributors, thankfully, both for wiki content. The wiki, I'd say, probably about 80% there in terms of content.
Yeah, it updated last night about 80%.
Mm-hmm. Whereas it was really bare before. So we got a lot of nastygrams. Hey, when are you guys going to put stuff out on the wiki? You just put out a list and a little bit of guidance. So we're actually working right now to beef that up significantly compared to before. So we have wiki content. These gentlemen from a handful of different places contributed. That's backwards, actually. That was wiki data. We had a handful of companies. So again, we had some SASE type of companies looking at a lot of different applications. We also had a few consultancies provide data from their user base and their customer base. So I'm going to turn it over. Cool.
All right, so Jack talked a little bit about, we had to look and step back at how the mobile app landscape has kind of changed. And we focused a lot on Android and iOS, but these are some of the things that are security enhancements that have happened in the frameworks, right? So either full or mostly by default support for ASLR, which is exploit mitigations in userland in applications, right? So this is pretty important. You don't want people to find overflows in your applications. So Apple and Android have enabled these either by default or made them super easy to implement when you compile the application. Data encryption by default. So now on both the platforms, you have the option, or you're forced to use at least some data protection. So this is specifically a line item for Apple. Recently with iOS 7 or with iOS 6, you could have a file with no data protection at all. Well, now with iOS 7, every file is assigned a data protection class, which means it's encrypted until the device is unlocked once when it's been powered on. That's what they apply to every file. You can apply higher levels of data protection, which is actually something we point out a lot when we look at these things. But at least they added something. Before, you could have no data protection and no encryption. You can instantiate per apps VPNs now to secure your network traffic path if you're a secure app. Both frameworks have added more MDM features, which make stealing devices and the threat from theft and loss a little bit less. There was a plague of lock screen vulnerabilities, if you want to call them, that came out like last year or something like that, and they've really mitigated pretty much those logic flaws that came out. And then certificate pinning, they've made it really easy to certificate pin in the Android platform. On the iOS, it's still kind of catching up to properly certificate pin, security-centric mobile app. So that's the OSs. The frameworks, the cross-platform frameworks that probably a lot of you are used to using, PhoneGap, Cordova, just to name the two top ones. Those haven't really changed that much. They're still focused on usability over security. So a lot of the caching and data storage that they do have not added any security features. And you're still looking at the same HTML5 bugs we were looking at 2 years, 3 years ago. So this is the mobile attack surface as you have to explain it to a customer when you're talking about mobile vulnerabilities. So you see here, you have your device on the left, and then you've got some icons, which we'll zoom into here. You have your network you're connected to, and then the servers that you end up connecting to run your app. So on the phone, you have a risk of basically a userland and then root jailbreak kind of exploit, right? Or root type of exploit. So these are things that completely compromise the whole OS. This is something like evasion that just came out, or a root type exploit. A lot of people believe that you have to have your phone tethered to deliver these kind of exploits, but that's not actually 100% true. If you remember 2 years ago or 3 years ago, jailbreakme.com did a remote root exploit of the phone strictly through the web browser. Those vulnerabilities still exist. You're not seeing them in the type of evasion releases. You're seeing tethered jailbreaks and tethered roots, but they still exist. They're mostly sold on the black market, and the NSA buys them too. So then you have the risk of theft and loss of the device, which is near and dear and close to my heart. A lot of people don't actually care about this. A lot of companies don't care about losing the device, or somebody, a competitor, or a malicious insider, someone stealing a device with sensitive information that your application has protected on it. This is a really big deal. A lot of apps are storing really, really sensitive information without you even knowing it. And the easiest way is just to steal the device or coerce the device away from someone. Multiple politicians have had their phones stolen just to get data out that, to use their services, their email, their, cloud services and stuff like that. So you have the risk of theft and data loss, or theft and loss. Then you have the networks that the applications connect to. So the thing you have to remember about a mobile network is either if you're on your carrier's network or you're on a local Wi-Fi, these are adversarial networks. There's always someone out to get you on these networks, whether they're trying to downgrade all your connections to unencrypted traffic, whether they're trying to brute force that session and span it and take all your data. And then whether the carrier has devices or routers that are actually trying to steal your data and give it to the government. So it's always an adversarial network. Then you have where your app sends data. Actually, can you go back one more? Thanks. So then you have your server, the server that you've stood up to deal with your application. And so there can be server-side vulns just like any web application, right? So that's actually one of the categories we're going to talk about. But as well as you do with everything else, you need to monetize and monitor your apps. And so then you bake in these ad and analytic frameworks that your traffic also goes to. And these are all in the cloud, and they get sent to multiple servers and backed up and all kinds of stuff. And your data is going everywhere without you even knowing it. So this is kind of the tiers of threats you look at for your data when you're threat profiling a mobile application. So this is a little bit about statistics. Really, I mean, the long and short of all of these snippets that you're going to see up here is that, when we looked at the number of apps in existence, the number of phone in existence, adoption rate basically says that more Android phones are being sold, but more adoption is going towards Apple very, very slightly. They're almost neck and neck right now. So this is the available apps in each app store. You can see that Apple and Google are neck and neck right now. BlackBerry and Windows Phone still have some market share. Windows Phone is actually trending higher and has a lot of the security features that you'd look for in Android and iOS, but it doesn't have the adoption yet. This is based on browser information, mobile browser information, so you can see that the web traffic and the app traffic that ends up on the internet, predominantly iOS over Android, and then just small slices of the pie from other vendors. And this is kind of what I pointed to earlier. Too long didn't read. Even though Android adoption is higher, Apple is winning slightly. Windows Phone is trending upwards. So this is the old top 10, where you have our 10 categories of types of vulnerabilities that you see the most in phone apps or mobile apps. So I won't read these all to you, but you've probably seen them before if you've ever looked at the project. And then this is the new top 10. Not much has changed. Some reordering of how prevalent the issues are, and then an addition of a new category, and then some added data. So the old on the left here, you can see that we took M10, which used to be sensitive information disclosure, which we called out to be hard-coded passwords in the binary itself, things that you could easily strings out or reverse out very easily to get at the meat of the application. We took that out and merged it into M1 and M4, which is M2 and M4, insecure data storage and unintended data leakage. There's a typo there. It's supposed to say M2 and M4, but that's fine. So we nuked that one and put it into some other categories. We renamed side channel data leakage because there was a lot of confusion about what side channel data leakage is. It's unintended data leakage. So we renamed that to unintended data leakage. It's moved up to M4. And basically it means things that the OS does that you'd never think that it actually does. These are things like caching and default logging, basically vulnerabilities that have to do with the OS, like backgrounding screenshots, things like that. So that changed name to make it a little bit more clear to developers what was happening. And then we added one more category, which is lack of binary protections, which is M10 on the right here. And that is all about the simple things you can do at compile time to protect your application against crackers and hackers and people who want to man in the middle of your application. So like I said, reordering based on a sample of 800 plus mobile assessments from the companies that contributed to us, mostly iOS and Android. We came up with roughly 250 unique vulnerabilities across all platforms. The top 20 of those 250 were 50% of those were server-side vulns. They weren't related to the client side. They were actually just really badly coded web servers that connected to the mobile apps. The rest were mostly data storage and lack of binary protections. That's why we added a new category and why you saw the move up for data storage. So like I said, lack of binary protections. These are some of the things you'll see inside of the lack of binary protections section that we added. Things like setting ASLR flags on compile time, using provided memory management frameworks so you don't have memory leaks that cause security and usability issues, anti-root and anti-jailbreak code that's sometimes very boilerplate to put in but thwarts a lot of cracking tools, not removing paths and symbols from compiled binaries, and lack of code obfuscation when it's really easy to use, like on the Android framework. The one we took out and we merged into the other categories was basically hard-coded keys and passwords and source. So this got moved into M2, which is unintended data storage, and M4, which is M4, which is unintended data storage, and M2, which is insecure data storage. So this got merged into the other two. And now I'm going to hand it over to Jack.
Okay. So a mobile application that doesn't have a backend to talk to is a pretty boring, crappy application. Additionally, so the way we pretty much rank these, 1, based on prevalence, 2, based on impact and likelihood. So I could either go up to one of you guys, steal your phone, or I could just slam the backend servers, right? Rip stuff out of databases. Think Snapchat, right? Why are you going to go after one phone when you can just pull the whole database? But we actually do see some interesting variances based on some of the mobile backends and web services compared to conventional web applications. We'll just explain kind of why we see some of those differences. So I think that one kind of got ripped off at the end there. So here's just an example of, and this is actually a challenge. This is one we expect that we're going to get the most flack about. We're going to get the most feedback, for better or for worse, is ripping out the web stuff or actually elevating it in criticality. So there are parts of the web top 10 that overlap with other parts of the mobile top 10. For example, authentication, authorization checks. It was actually kind of challenging to figure out if we lump them all in one place or we kind of break them out. So we broke them out. So again, this isn't a draft status. So if you have feedback from the community, we're definitely interested in hearing it. So we do see quite a bit still of injection. We see a lot of mass assignment. Probably, I think, a lot more than people realize is out there. So some of the newer frameworks, MVC frameworks, are really prone to this stuff. So whatever you want to call it, whether it's mass assignment, auto binding issues, schema injection, whatever you want to call it. But really, we see a lot of mobile development shops. They're not building quite as many Java backends. They're using Rails, they're using Django, they're using Node. They're using platforms like Parse, StackMob, to where you can get up and running really quick, and you just have basically, schema store where you can dump data. And when you have those types of things, well, then you run into issues like mass assignable type of models and stuff like that. And good apps like hygiene. We still see a lot of, pick something, Sinatra, you haven't seen it updated in a couple of years. We still see quite a lot of that stuff as well. So mobile, development shops just using really outdated versions of newer frameworks, if that makes any sense, kind of, sort of. But we still see quite a bit of that stuff. So our recommendations, really we could just say seeing like the web top 10. But if you know how to protect the web service, well then you know how to protect the mobile backend in most cases. So, all the things we know about, preparing statements, protecting, for example, what can actually get passed into something that updates a model, which leads to mass assignable type issues. Configuration flaws, anything you would do to a web backend or a web service, think you'd want to do that here as well.
So M2 insecure data storage was formerly M1 in the 2011 draft. So this is every way you can store data. So here we have an example of an iOS application that uses a database storage record, and it's storing a password for a user in clear text. This is another mobile project called iGoat. It's a vulnerable mobile application by design. We did not design it. Ken Van Wyck designed it. But it helps developers and AppSec testers learn the issues, right? So what you're seeing here is a login field. Once you log in through the application, your credentials get stored in a SQL database as plain text. What it doesn't show here is actually that file has no data protection class, meaning that if someone steals your phone, they can just pull it right off of the phone without ever putting in a PIN. So insecure data storage is now number 2. But examples in this category are no data protection with files at rest, and this includes both SQLite database, plist files, binary data stores, XML files, whatever you're storing into, text files, whatever. You need to add a data protection class to these type of files. So weak data protection at rest is also prevalent, where people are adding something or expecting the OS to add a data protection class, and it's by default, it's adding a very weak one, saying when you can get your data, you can just plug your phone into a computer and grab that data, and then public storage of these files in world readable folders on the phones themselves. So the first thing is don't write to shared folders. So on iOS, don't write to var temp. If you're using the photo roll, use the sandbox photo roll, not the UI application image store all class or method, which stores it in the public photo roll, which all your other apps can read. Don't store on your SD card if you're on Android, because all the other apps can read most of the data stored in the SD card, or don't store in any multiple readable application. So on iOS, with those files that are inside of the sandbox area, apply a higher data protection class on them. So the default one that's given to you when on iOS 7 to every file is the first one there, NS file protection complete until first user authentication. And like I said, that means that if you powered on your phone once and you put in the PIN once, someone can, your phone can then go to sleep and someone can still plug your phone into a computer, pull your files off if they have that data protection class on them without putting in your PIN. So as long as the phone has been powered on once and the PIN's been entered in once, you can steal the data. So that's the default one that's put on all files in iOS 7. So add a better one. Add NS file protection complete, which means at all times, unless the app's running, the file is encrypted. Complete unless open. So if your image backgrounds gracefully or it has a backgrounding mode and you keep it open, your file is unencrypted. But when you close that app or it's closed via the task manager in iOS, it's back to encrypted state. Android, don't use mode world writable on any files ever, because that means all applications can grab them. And these are just some recommendations. The wiki has more recommendations for each platform. So we actually put in a ton of work last night and this whole month updating some stuff. There's a lot of stuff still to be done, but all of this information is also on the OS Mobile Top 10 wiki. So that's insecure data storage.
All right, so the next one up is insufficient transport layer protection. So this one actually stayed in the same place it was a couple years ago. So we still see just as much of this in the wild as we did before, and there's not really much in terms of changes. Would it actually both iOS, Android, even Windows Phone pretty much offer out of the box. So under most circumstances, if certificate issues, for example, untrusted CA or server name doesn't match, generally they should throw exceptions with the default classes. But of course, developers do all kinds of different things to get around that behavior, and I'll talk about a few of those. So here's, for example, this is actually code in GoDroid, and I can't actually take claim for that code because I ripped it off of Stack Overflow. If you're looking for vulnerable code and just, Darwinism type of stuff, Stack Overflow is your best bet to find that kind of code. So this example here, and this is something we see, fairly commonly. A lot of applications that just haven't been touched, startup out of the gate. See this, I'd say, probably between 40 and 50% of applications across the board. So in this example here, they just used their own trust manager, and they caught those different things. And basically what happens, we don't throw anything. We just have to do auto-generated. So nothing actually happens. So in that scenario, you actually just end up failing open. Things fail. Could be, untrusted CA, server name that doesn't match, somebody bad sitting in the middle, and we just basically fail open in that scenario. There's a couple root causes for that. One of the biggest ones is development teams that might be using like self-signed certs in a dev environment, and then they want to go to production, and it works, right? So you're under a tight deadline, you have to ship a product, and it works. Are you going to go and uproot everything that works? You're not going to do it. You're going to leave it as is. So people have quick timelines, they ship, they don't test these things, and this kind of stuff happens in the wild. So Jason alluded a little bit before to some of the stuff that ad and analytics networks do. If you drop these different APIs and different SDKs into your applications, you really need to know what you're enabling. So there's some really popular ad networks that we're not going to mention by name that actually disable SSL checks. So bad guys sit in the middle, they can read your data. So some of these ad networks are pretty atrocious for what they pull from MAC addresses to phone identifiers, demographics, so on and so forth. All the great things that ad networks pull. And a lot of times this stuff can either travel unencrypted, where they might not be encrypting at all, or they're disabling SSL checks, and it's man-in-the-middleable. Certificate pinning. So it's a really great idea. Everyone should do it. Anybody want to take a guess for how many applications, what percentage of, we'll pick like the top 500 to 1,000 iOS and Android. Anyone want to take a guess percentage-wise how many apps might actually be doing pinning at this point? Pretty in that range, right? So I mean, you see, the big social nets have done a good job of adopting it. Big banks have done it, and it just pretty much a handful of commerce apps, and then it just pretty much just node dies after that. Not a lot of people are pinning it. It's not really so within the security echo chamber. Who's heard of certificate pinning before today? Okay, right. So we're security people. A lot of us have heard of it. The average developer that just hasn't been exposed to security has no idea what certificate pinning is. There's nothing really. I mean, if you read through the security documentation I don't know if really there's much mention on iOS developer documentation. On Android, when you look at the security, recommendations for Android, there is mention of certificate pinning. But if you're a developer that just wants to get an app out, you're probably not going to read it up and down. So we see, little adoption. Yes. Okay. So certificate pinning, basically, instead of trusting the CA chain, so you might have something signed by, GoDaddy, whoever, issue the certificate. So you're actually just completely evade, getting around that whole chain. You would, ship your application with the public key, with the hope that whoever's going to decrypt another side is going to have that, private key to. So basically, you're explicitly saying who those two endpoints are. As opposed to if you're just basically letting it be up to the CAs, well then you have to rely. So we live in a paranoid world, right? The NSA, we're not going to talk about that much. But in previous years, there's been a lot of CAs that have been compromised, dirty CAs, issuing signing certificates to various groups. So a lot of flack for that. A lot of people have lost trust in that whole process. So certificate pinning has gotten popular in the absence of trust. Additionally, something else we see as well. So we see, for example, hostname verifier type stuff, where you'll actually look to say, we only want to talk to this particular server. As lots of issues with that. So we see a lot of applications where you end up being like basically wildcard. We can talk to everybody, or potential issues with casing, so on and so forth. But when you try to implement that behavior, most people screw it up. So really a handful of recommendations. So your application, if it encounters any type of certificate errors, it shouldn't allow the application to continue talking to that server. It should basically kill that and hopefully alert the user that something bad's going on. They might be using an untrusted network, man-in-the-middle type activity going on, and they should proceed with caution. Doesn't always happen. Another thing that we see is where it'll fall back to plain text. So in other words, we encountered an issue, couldn't do an SSL handshake for whatever reason, and that's cool. We're going to ignore that, and we're going to go plain text or HTTP. Don't do that. Fail close. Just stop at that point. If you're going into, it's fine to use a self-signed certificate in development, but when you go to prod, get rid of that. Use a real certificate or PIN, one of the two, but don't use a self-signed cert in a prod environment. And if you could do certificate pinning, which there's a lot of actually really easy code you could drop into your app out there, there's options out there to be able to pin pretty easy. Android is making it a little bit easier in more recent versions, but Apple I don't believe is offering much in terms of.
There's some security companies who have come out with good code for pinning certificates. One of them I want to say is ISEC Partners. I think really respected mobile security group. They did a black hat talk all about certificate pinning. So if you're really interested in certificate pinning and how hackers bypass it and how you can make it pretty ironclad, those links I will actually put up on the wiki tonight so that you can check them out because they're a good resource for this specific topic. Cool. So we've kind of talked about the mobile threat landscape. We've talked about what the reordering was. We added some stuff. We moved around the numbers, but not a ton has changed. So what's next for the project as a whole? We have 90 days of community feedback, and this is kind of where you guys come in, right? So we've gotten a lot of data from a lot of companies, but not enough companies. We went out to a ton of respected mobile vendors, and we didn't get as much buy-in as we thought we were going to get for a project that is as important as we think it is. So really, we'd like to spend the next 90 days getting emails from all of you. If you think our project sucks, you think we're referencing something bad, you have some input, you want to update the wiki, we will work with you to do that. We want your help. Please help us. So we have 90 days to finalize that. So then we take all that feedback, since we're, I guess, kind of the experts, we go over it and figure out what should be the industry standard, and we merge it into the wiki content. And then, just like the web top 10, we publish a formal PDF, kind of a threat matrix document, as well as a secure code guidelines document. This document is a PDF that OWASP developers can download, give to their or download and use practically in the world. Also, we update all the content on the wiki so anybody can go there and check it out. And that's it.